Page 378, we're going to take your brains back a long way to a very simple rule that when you have an equation and you multiply both sides by the same number, you still have a solution to your equation, correct? Yes, you do. Because if you had 3 equals 3 and you multiply both sides by 5, what do you get? Equals 15, right? Now, let's try something. What happens when we do this? What is 5 equals 2 plus 3? What if I multiplied both sides by 5? Would that still be a true equation?
Yes.
Mm-hmm.
Would it be? If I multiply both sides by 5, I get 25 equals
25.
10 plus
15.
15 equals 25, right? That's a rule that you should have learned a long time ago, right? Today, at least the first part of today, what happens when you do that by a negative number? So what happens if I do it by, multiply this by negative 5? Will I still get the same result? Would I still get the same result?
Yeah.
I do?
Yeah.
All right. What is that? What do you, okay, so I get negative 25 equals negative 10 plus negative 15. Does that still work? But now I want to take you back. Now I'm pause for a second because my brain hasn't. All right, so now let's take a look at an inequality. So it still works when we're doing what we did. But what about this one? 7 is greater than 2. Oh, man, greater sign looks like a 7. 7 is greater than 2. What happens if I multiply both of those by negative 2? I get negative 14 is greater than negative 4. Is that true?
No.
No. Now all of a sudden I have something that's false. Right? But if I reverse the inequality symbol when I do that, though, I can make it true. So if I went back to my original one, 7 is greater than 2, and then I multiplied it both by negative 2, and in the process of multiplying them both by negative 2, I reverse my inequality sign. Is it true now? Yes, it is. So therefore, I have to be very careful that when I am doing a problem like this, and I'm asked to graph that, I have to know what I'm doing. And I'm not going to worry about the graphing part because I know you know how to graph it by now. But what happens to a sign? What do I have to do to get my variable isolated all by itself? I'm multiplying by negative 1. So what do I have to do to get rid of my negative 1? I have to divide by negative 1 on both sides because I'm already multiplying. So since I'm multiplying by negative 1 on both sides, and I get rid of that negative 1, what do I end up with? what do I end up with? To get rid of that negative, what happens to the 2? It becomes negative. But because I moved my negative across an inequality, what else do I have to do? I have to switch the sign. So now I have x is greater than or equal to negative 2. And now I can graph it. I didn't flip it, did I? I meant to flip it. X is less than or equal to negative 2. Because I have to flip the sign. So anytime you're moving a negative that's being multiplied across an inequality, you have to flip the signs. So here's another example. 4 minus x is less than or equal to 6. And the domain is integers. So if you were to graph integers, you know those are the dots. If you were to graph integers, the first thing I would do is subtract 4 on both sides. That does not flip the signs. Now I flip the signs. X is greater than or equal to negative 2. All right, so you have to flip the signs. All right, and even in the more complicated ones, like negative 3x plus 4 is less than or equal to 13 with the domain of real numbers, if I subtract 4 on both sides, I get negative 3x is less than or equal to 9. And then I divide by negative 3 on both sides, I get x is greater than or equal to negative 3. Okay, so I also have to flip my sign because I moved the negative across, right? And we never had to do that when we were talking about, lost my train of thought again. I never had to do that when we had equal signs because we flipped an equal sign, still got an equal sign, right? But with an inequality, it's a little bit of a different prospect. All right, moving on. New thing. Transition. Something totally different. I'm not sure why these are piggyback, but you know, that's life. We're going to see how poor my artistic skills are. Looks like an egg. All right, assume that's a sphere. This is not. All right, how do you find the volume of a sphere? You're here! I know. Welcome. I have a video for you to watch when I'm done, when I get it uploaded. Welcome. How do we find the volume of a sphere? And yes, I know I did not draw a sphere. All right, well, what in sphere world, you have something called a radius still. Okay? In sphere world, you have something called a radius. And your radius extends from the center to the outside of your sphere. And yes, I know that looks like an egg. Kind of. A weird egg, but an egg nonetheless. How do you find the volume of a sphere? Because if I had to put my sphere inside a cylinder, which I shouldn't dare attempt to draw since I obviously can't draw. So here's my cylinder. Okay. My sphere does not, my cylinder is bigger than my sphere. Right? My cylinder is bigger than my sphere. But if I want my cylinder to cover as much of that sphere as I could, so the sphere is touching the top and the bottom, then the height of my sphere, or the height of my cylinder from top to bottom, is 2 times the radius. Because notice my original radius is going from the middle to the outside, to the top. But so it's double. So the volume of a sphere is done like this. How do you find the area of the base of a cylinder? Cylinder's got what kind of shaped base? All right, it's a circle, right? So area of the base of a cylinder is what? Pi r squared. All right, so that's the base of my cylinder. Okay, the base of my cylinder, pi r squared, right? How do you find the volume of a cylinder? Well, what's the height of my cylinder? I told you. It's already written down.
4.
No, it's 2r. 2 times the radius.
Oh.
Right? The height of this particular cylinder is double the radius of the sphere. 2r.
The radius was only 1? The sphere?
I didn't say what the radius was.
Oh.
The radius is here. The height of the cylinder is double the radius. Okay? Because if it went down to this side, it would be double it. Okay? Well, here. There's the bottom. I missed.
Oh.
All right? So the height, to find the volume of a cylinder, you're going to multiply it times the height, right? So I'm going to multiply it by the height, which is 2r. Correct? So now if I multiply this by 2r, I get pi r to the third power. With me so far? Well, the sphere isn't, the sphere inside the cylinder equals a special number. If you had a cylinder that could perfectly fit a sphere, then the difference between the two is 2/3. So 2 pi r third, I forgot to write the 2 there, 2/3 times 2 pi r to the third is 4/3 times pi r to the third, or basically 4/3 pi r to the third power. Basically, all that means is that's the formula for finding the area of a sphere and why that's what it is. So the formula for the area of a sphere, for something that you could learn and write down and inwardly digest, is 4/3 times pi times the cube of the radius. That's for the volume of the sphere. That's how you would find the volume of the sphere. Now, I never said what the radius was, did I? Never said what the radius was. So the radius is 3 centimeters. If the radius is 3 centimeters, what is the volume of that sphere? What is 3 times 3 times 3? Times 4/3. $36 times 3.14. Almost there. $3.14 because pi. 113, excuse me, 0.04 cubic centimeters. Very good. Okay? Not too hard if you know the formula, is it? But I spent all that time just showing you how the formula works. If you don't remember that, it doesn't matter, because what you need to remember is it's 4/3 pi r squared. R cubed, I did say squared, but I shouldn't have. All right, one more thing. And I'm going to run out of time on this. Surface area of a sphere. Not hard. Not hard. Not complicated either, if you think about it. All right, surface area of a sphere basically means if you could cut a sphere up, you can cut it up into 4 circles. All right? It's an easy way to remember surface area of a sphere. How do you find the area of a circle? Pi r squared. So pi r squared, weird pi. This is surface area of a sphere. Woo, been around time. All right, so pi r squared is the area of a circle. What if I told you that a sphere is made up of 4 circles? What do you think the formula would be?
4 pi r.
Done.
Really?
What if I told you?
So what if I told you that the radius of a circle was 2 centimeters?
Oh, just 2.
So r squared would be 4. 4 is 16 times 3.14, and you have the surface area of that sphere. Right?